The eSCOPE Elite 8 is designed by automotive technicians, for technicians. It truly is the easiest and most intuitive scope on the market, designed specifically for the automotive industry. Don't waste time fighting with your scope. Our software is powerful, intuitive, and stable. Just turn it on, connect to the vehicle, and get your data fast. You can analyze cam, crank, ignition, fuel injectors, communication buses, pretty much anything, just by simply connecting the eSCOPE and hitting the deep record button. You can zoom into the waveform to see the data you need to diagnose a vehicle. In this example, we can see the ignition coil burn times. The waveforms are sharp and clear even as we zoom in to milliseconds. The eSCOPE Elite 8 is perfect for solving drivability problems, engine misfires, charging system issues, diagnostic trouble codes, and more. In addition, many OEMs are now including waveforms in their diagnostic and technical data. It's important to invest in a scope capable of diagnosing and repairing modern vehicles. ATS keeps mechanics at the center of what we do. We have your back with our tech support and offer 3-day bootcamp classes designed to make you proficient at diagnosing and repairing vehicles with the eSCOPE Elite 8. The eSCOPE is easy to set up and start using, right out of the box. It's packed with useful tools and features to make your job easier. The eSCOPE makes setup easy. There is no need to use external attenuators. Our scope's attenuators are internal and automatically applied, up to 500 volts. In just a few minutes, the scope is set up and recording data. Right from the start of a diagnostic session, our unique auto detection feature ensures that you're not wasting time fighting with a poor electrical connection. At the top, click on the Meter tab. Red indicates a bad connection, gray indicates a solid connection. Don't waste time in your diagnostic sessions second-guessing if you have a good connection. The eSCOPE Elite 8 eliminates the guesswork. The eSCOPE's default values are set for the majority of the tests you will run. There is no need to set scope voltage and time base. The eSCOPE just gets the diagnostic data you need fast. It's that easy. Now let's take a look at the deep record function. To start a diagnostic session, we need to gather data and record a waveform. At the top of the screen, click on the Measure and Deep Record tab. To start, click on the Start Deep Record button at the top. When you have recorded your data sample, click on the Stop Deep Record button. To save this data, click on Save. In the window that opens, we can select as much or as little information about the vehicle as you want from the drop-down menus. Let's look at a 2012 Jeep. You can see the fields are pre-populated with Jeep information. If we change it to GMC, you see the options change for GMC. Select the year, engine size, and transmission. Here, we can select that we are looking at the engine system. Now, when we look at the channels, we can see that it is pre-populated with all the possible information related to the engine system. Now let's change from engine system to headlights, and the information in the channels changes to options related to the headlight system. Let's change it to door locks, and we will see the options in the channel drop-downs change again. Now, click Save Data, and all of the information related to the vehicle this data was recorded from will be included in the file. If we reopen the file, you will see that it saved all of the information we selected from the drop-down menus. Now, let's take a look at some features built into the eSCOPE. Let's start by looking at a saved file and get familiar with some basics of using the scope. Analyzing saved files is easy. Click on Load, choose the file, then click on Load Data. The screen manipulation options are on the right-hand side. With our touchscreen tablet, it's easy to pan, zoom in and out, and move the waveform on the screen to see exactly what you need. The eSCOPE is a true 16-bit scope, and the waveform stays sharp and clear, even under heavy magnification. Zoom out to full zooms out to show the entire recorded waveform. Next, let's explore the zoom set, zoom to set, and zoom undo options. Let's start by clicking on Zoom window. Draw a box around the section you want to view. Let's do that again to zoom in more. Now, click Zoom Set. Basically, you have set an anchor on the waveform. If we click on Zoom Out to Full, the full waveform is displayed again. Now, when we click on Zoom to Set, it will zoom in exactly to the point on the waveform where we had clicked on the Zoom Set option. Now let's click on Zoom Out to Full. We can zoom in to see small sections of the waveform, and we can undo that zoom simply by clicking on Zoom Undo. In this example, a cam crank waveform. The waveforms are overlaid on top of each other, with the values going negative and positive from 0. You can adjust the image simply by clicking the up or down arrow next to each channel on the right-hand side of the screen. Now, click on Zoom Out to Full. You can see that we have moved channel 1 to be offset from the other channels. If we click on the yellow dot, the waveform position reverts back to where it was originally. Next, simply click the All button, and the waveforms in all of the channels will separate at once. Now, we can zoom in on it. If we want to make fine adjustments, we can click the arrows and move each channel independently. Now we can zoom again on the waveform if we want. We can put everything back where it was by simply clicking the All button, and it will revert back to its original position. It's important to note that this data was captured without changing any parameters or settings on the left-hand side of the screen. Now, let's analyze a waveform for fuel injectors and take some measurements with the cursors. Let's start by zooming in on the injector waveform. Click on Zoom Out to Full. We can make channels visible by clicking the On or Off buttons on the lower right of the screen. Let's zoom in further and use cursors to measure. Let's put a cursor at the point where the PCM was commanded on. This line is source voltage coming in. It's commanded on, and it pulls to ground. Let's place another cursor at the point where the PCM was commanded to release the injector. We can see on the right side of the screen that the time interval between when the PCM is commanded on and then off, the injector on time, is 3.271 milliseconds. Now let's zoom out to full, and we can turn the other channels back on. Now let's explore our unique auto-scale function. We will start by loading a waveform to analyze. Here we can see that the first channel is measuring negative or positive pressure in inches of water. The second channel is the ignition coil. The third channel is a 300 psi pressure transducer, and channel 4 is another pressure transducer measuring vacuum. Select the file and click on Load Data. Drag a box around a section of waveform to zoom in. Then choose a section with 2 compression towers and zoom in again. The green line, channel 3, is pressure, and we can see that it reaches 85 psi. The red channel, channel 2, is the 5-volt reference from the ignition coil. We can see from this scale that it indicates 5 volts. The blue channel, channel 4, indicates vacuum, and we can see on the scale that it indicates 15 inches of vacuum. The yellow channel, channel 1, is the exhaust pulse. All of the measurements are displayed on the same scale, making it easy to read the measurements. No other scope is able to overlay all of the waveforms, displaying all measurements in the respective unit of measure on one screen. The auto-scaling feature is unique to the eSCOPE Elite 8. Now, click on Zoom Out to Full and you will see the scale adjust automatically. These towers on the green channel are where the tech has done a throttle snap, where the throttle pedal was pressed to the floor and released. We can see that the first throttle snap increased the pressure to approximately 260 psi, and the second throttle snap increased the pressure to just over 300. Let's undo that zoom and get the cursors. Drag a cursor to the center of the compression towers. Now, let's mark the camshaft. This feature is also patented and unique to the eSCOPE Elite 8. We can see our 180, 360, 540 and 720 degree marks, the top dead center and bottom dead center marks, and the intake, compression, power, and exhaust strokes. Now we can measure valve openings, which is the green channel. Let's zoom in to make it clearer. First, we will do a zoom set. Then zoom in to that point on the waveform. We can see where the green line starts. Its upward swing is where the exhaust valve opened. These tick marks indicate the crank rotation in degrees, 30, 60, 90. Here we can see the exhaust valve opening between -30 and -60 degrees. Here is where the exhaust valve closed and the intake valve opened, and we can see a pressure drop. If we follow it to the right, we can see by the upward swing that the intake valve has closed. The pistons are traveling up, building pressure in the cylinder. Click Zoom to Set to return to the point we marked on the waveform. Now we are going to overlay the firing order on this waveform. Click on Mark Cylinders at the top of the screen. It will let me know that I have already marked the waveform, so I click OK. This file was made in cylinder 5. Select Ignition, and the firing orders are built into the software. So let's choose the correct firing order for this Cadillac, and you'll see it overlaid onto the waveform. Now let's click on Load. Let's mark a cranking waveform. Click on Load Data, and then we will zoom in on 2 compression towers. Click on Get Cursors, and drag a cursor to the center of each compression tower. Click on Mark Cylinders and mark it as Intake. Now we see the firing order overlaid onto the waveform. Now zoom into the intake, which is the blue channel. Let's mark the cylinders again. Here is the firing order. We can shut channels on and off. Now we are looking at just vacuum. We can clearly see that the vacuum dropped on cylinder 5, indicating a leak. We can zoom in again, remark the cylinders again, and we can see the leak clearly. We can zoom back out to full, turn our channels back on. Zoom out to full again, and the display will auto-scale. The eSCOPE Elite 8 features built-in tests, which are unique to the eSCOPE Elite 8. Click on the Tools tab at the top. Let's look at the patent-pending CKP misfire feature. This test is quick to set up. There are only 3 connections to be made: the battery ground, crank signal, and ignition coil. The scope is going to look at the acceleration and deceleration of the crank. To start, we either need to open a saved file to analyze or connect to a vehicle to gather live data. Let's get set up on a Ford Escape by connecting to the battery ground, crank signal, and coil. And then we'll click the Deep Record button. When you have recorded a short data sample, click Stop Deep Record button. Let's zoom in on the waveform. You can pan over until you see a section of the waveform you want to analyze. Now let's run the CKP misfire test. The eSCOPE uses the crankshaft signal to identify changes in the crankshaft velocity. At the top, click on Tools. Now, let's select the correct firing order for this engine from the drop-down menu. Select whether the ignition is a waste spark or not, and select the correct trigger cylinder. Now click on Start Test, and the eSCOPE will begin recording and analyzing the data. We can see that in this data sample, 10 misfires were detected in cylinder 3. We can see the misfires here on the waveform, and here on the detailed results screen. Now let's run the compression test by connecting to the positive and ground on the battery and the coil. At the top, click on Meter to check that the connections are good. We can see by the gray box that the connection is solid and reading 12 volts on channel 1. Now click on the Tools tab at the top. Make sure that you are on the compression screen. Click on the Start Test button and follow the instructions on the prompt screen, and crank the engine for 8 seconds. We can see in the results that a compression leak is detected on cylinder 3. On the left side, we can see the detailed results. Now let's take a look at another feature that is unique to the eSCOPE Elite 8, the signal output. No other automotive oscilloscope on the market can do this. This capability allows you to test fuel injectors, coils, and solenoids. Basically, any component that is activated by pulling the circuit to ground. Start by selecting the Output tab on the menu at the top of the screen. For this example, we will use a light bulb so that you can visually see what the output signal is doing. We have an auxiliary cable, which is included with the eSCOPE accessory kit, connected from the pull-down out port on the scope to the ground side of the light bulb. The bulb has a constant 12-volt source voltage, and we are going to send a pulsed control, grounding the circuit and causing the light bulb to strobe. This is a visual representation of exactly what the ECU does when commanding an injector or coil on or off. You can see the correlation between the waveform and the light pulsing. We can control the time, frequency, and duty cycle from the software. This signal output pull to ground feature is only available in the eSCOPE Elite 8. You can expand the power and capability of the eSCOPE Elite 8 with the addition of our IEA, Intelligent Engine Analyzer. The IEA is a comprehensive pressure transducer kit with software for misfire detection that brings even more patented diagnostic technology to your shop. With the IEA, you can view in-cylinder, intake manifold, and exhaust system pressures simultaneously. The eSCOPE Elite 8 is the only automotive oscilloscope which can drive multiple pressure transducers at once, displaying the results in their respective units of measurement, with crystal clear waveforms on one screen. With the IEA, you can quickly find where the pressure is leaking, the intake valve, exhaust valve, or piston ring. With the Intelligent Engine Analyzer, you can easily identify camshaft timing issues through the spark plug hole. You can tell if the camshaft timing is off by as little as one tooth. Are you trying to diagnose a random misfire code, an incorrectly identified misfire code, or no code at all and the engine is misfiring? The IEA shows which cylinder or cylinders are misfiring through the exhaust tailpipe, and then checks the mechanical condition of the cylinder through the spark plug hole in just a few minutes. Save yourself hours of diagnostic time with the eSCOPE Elite 8 and the Intelligent Engine Analyzer. Equip your shop for the future today.